You're going to fold your foldable in half along this line. And then you're going to cut along that line. So using our scissors. Right along this line right here. So that we have our two flaps. Okay. Looking at the first one, we're going to talk about domain. Domain is the set of possible x values. These are all of our independent variables. Okay, so when we're looking at domain, we're looking at how does it go along the x-axis. So if I look at my interior, and we've talked about discrete and continuous data, the first three we're looking at, these three are all discrete. I'm talking about individual points. Now, when I'm looking at a specific set, so here this is a mapping diagram, my domain is my x values. So these are really simple. I'm just simply going to take all those x values and listen. We're going to say my domain, so D, includes, and we use a little colon. And then when we do our list, we use this curly bracket. So I just list them. I have -2, 3, 4, and 10. And that's it. I'm just making my list. Same kind of idea when I have a T-chart. I'm looking at my X column. And I'm going to do the same thing. I'm just simply listing them. So my domain includes the list 0, 2, 4, 6, 7, and 8. So either of these two representations are very simple to write our domain from because it's just listed there for us. When I get to a discrete graph, now I'm going to look at each point and look at their x value. So one way to do that is to look at that line and go, where does it hit the x-axis? If I look at each of them, these ones, I have 5 here, and then I have a 6 here. So my domain, and because it's discrete, I'm still having a list, is just 1, 2, 3, 4, 5, and 6. So we're going to talk about this one later. For your reference, this is a continuous graph. So when we do continuous graphs, I'm still looking along the x-axis, but notice the line keeps going. There's not set points like over here. And I look specifically at these two arrows. So because those arrows are going to continue going forever to the left and forever to the right, my domain is going to be the range. Going forever left is going into the negative infinity zone. And then it's going all the way into the positive infinity zone to the right. So I leave that range, that interval, like that. And say it could be any number that I can pick, because it's from negative infinity to positive infinity. We'll talk more about these later. So that's the domain, my x values. My range is all possible y values. These are my dependent variables. So I'm looking at the range. I'm looking at my y-axis. So again, if I open it up, my first three, just like the other one, these are all discrete data points or data representations. And my other one is continuous. Just like I did with domain, when I wanted to find my x values, I just listed them. When I want to find my y values, I just list them. So my y values, I'm talking about a range now, so R includes the list of -1, 0, 2, 4, and 6. For my input-output table, I'm looking at the other column. That's my y values. So here my range includes, and we go smallest to largest. So looking at this, 0 is my smallest. I'm not repeating the 2 zeros. So my next one will be 3, then 5, 7, and 10. If I'm given a discrete graph like this, now I'm looking at where those points hit the y-axis. So over, this is a 0, 1, 2, 3, and 6. So in this case, my range is -1, 0, 1, 2, 3, and 6. So those are all my discrete data representations. If I have one that's continuous, I'm still looking at my y-axis, but this time I have a limit. So I'm not going past this point. So my range, because it's a solid ending, I'm going to use a square bracket. My range is going from -1 all the way to, and because I have, again, these arrows that are going up, I'm going to say it's going to keep going up and up and up and up and up. So it's going all the way to positive infinity. Okay. So you're going to take these and you're going to glue it into